This lesson is called Modeling Direct Variation. Ties in nicely with graphing because it is graphing that two things vary directly and there's like one variable, one aspect that you have to consider of the equation. So we'll talk about that more, but let's say two variables show direct variation. If y equals a times x and a doesn't equal 0, which would be kind of pointless. So big deal. What's that mean? I mean, so far, what's this equation missing based on the graphing we've been doing? Well, there's no y-intercept. I'll give you some examples of this in a minute, but what it's saying basically is you do something and it has an immediate effect on something else. Um, a lot of science and business has a direct variation, so we'll get to that. Now, some of the math problems we'll see are which of the following are direct variation? Well, write them as y equals ax and see if there's a y-intercept. So this one is direct because there's no y-intercept. This is not direct, and it doesn't mean it's indirect, it's just not direct. This one we're not sure, so let's do some manipulating. Looks like it's direct. Yes, it is. There is no y-intercept. Does it matter what the slope is? No, it does not. As long as it's not 0 and there's no y-intercept. This one's going to be not direct, but we'll go through the process anyway. Get that y alone. Y equals negative x plus 4 over 3, not direct. So when you graph them, it's pretty easy. Y-intercept 0, so always your first point is always 0, 0. What are some examples of direct variation? Well, the one that most people know is your pay is directly affected by the number of hours you work. Your grades, and it's a different direct variation for every person because some people get it easier than others, but your grades are a direct variation of number of hours you put in. Your number of goals you score in a game or baskets or whatever varies directly with the number of games. In physics, we have F equals ma. And if it's a gravitational pull, for instance, a rock falling, then the force varies directly with the mass. More mass, more force. Less mass, less force. So those are some examples. What's the purpose of this lesson? Well, I already said. You'll use this in business and science. It's a simple example of graphing. Linear function. And speaking of linear functions, the next lesson we do is actually pretty straightforward, but it changes things and really freaks a lot of people out. This is sarcasm, which I am fond of. So instead of writing y equals 2x plus 1, we write a linear function. We say f of x equals 2x plus 1. It is not a big change, but it freaks a lot of people out. They don't understand f of x. So f is a function, meaning that y here depends on what we put in for x. So instead of writing y equals 2x plus 1, we'll say f of x equals 2x plus 1. The function depends on what we put in for x. So that's how we say it. F of x equals whatever. And a function is a good model. You will have math teachers for a long time tell you a function's this, a function's that. Try to remember, it's a good model. I write a model to tell me what temperature it's going to be on June 1st or September 17th or January 5th, a good model would give me a single answer. A bad model would say, oh, on September 15th, it's going to be 38 degrees or might be 72 degrees. Who knows? So a good model is a model that gives one answer. We'll come up with easy ways for you to test whether things are functions, but for now, anything linear, anything with a single power, is almost always going to be a function. For the purpose of this class, you can basically remember that. So here's how we write it. F of x, but we're going to say x equals -3. So f of -3 equals 3 times -3 minus 15. So f of -3, notice I'm writing it with a nice script now, you can write it either way, equals -9 minus 15, which is -24. That's it. If it makes you feel better, quite a few people it does, write it as y equals 3x minus 15 when x equals -3. And that's fine. You can just put that into y equals 3 times -3 minus 15, which is -9, minus 15, which is -24. If that makes you feel better, go right ahead. Not a problem. Same thing here. How would you graph this? Well, we just rewrite it. Y equals -3/4 x minus 1, m equals -3/4, b equals -1, and we go. Smaller graph here. And we just write it out. Down 1, -3/4, 1, 2, 3, 1, 2, 3, 4. Done. And something that pops up a lot, so I wanted to put it in here. Make sure everybody's clear on it. What's a graph of y equal x look like? Well, what's the slope? M equals 1, it's the invisible 1 right here. And b equals 0, invisible 0 right here. Plus 0, I should say. So when we graph it, it goes up 1 over 1. Starts at 0, 0, up 1 over 1, so on and so on. Y equals x graphs as an angular line, and we call it a 45-degree angle. We will touch on this more. For the time being, try to remember that. It pops up fairly often in geometry, a little bit in Algebra 1, a lot in Algebra 2, pre-calculus, and calculus. So, went over all this before, but let's talk about it. If we have a line, and this time we're not going to put in anything, if we add an intercept, what's that do? Well, it just moves the line up or down. So if we had the line y equals x, it's a 45-degree, it's supposed to be going through 0, 0, and adding an intercept, we'll just positive intercept, will move the whole line up, negative intercept, will move the whole line down. If we have a positive slope, it goes up to the right. Negative slope goes down to the right. A fractional slope, like 2/3, negative there, or 1/5, or 9/10, or 1/100th, will give you a flatter line, and it'll be a flatter line than y equals x. That's it. Get to work. Lots to practice.